I'll have a wonderful day to you all. The title of this video is What ARMA 3 Gets Wrong. And what ARMA 3 gets wrong, it's the magnetic declination. So I can't really explain what it is. On ARMA 3 it is not modeled really. So I will use a real POP 2M and I will use the real map and real scenario. Well, what magnetic declination is and how to calculate with it. What you need is obviously your POP 2. You need a map. You need to know your location, and you need a pretty good visible terrain feature like this tower over there. And the other thing you need to know is the azimuth, the true azimuth. The true azimuth of that known terrain feature, like that tower, from the true north, not the magnetic north, from the true north. And now we are going to measure the magnetic azimuth of that tower, and out of the true azimuth and the magnetic azimuth, we are going to calculate the magnetic declination. So let's do it. First we need to set up our POP 2. You see, you need to undo these bolts on all the three legs and just pull them all the way out and tighten the bolts again. Obviously do it on all the three legs. And you see, then you set your tripod up to a comfortable height, and you need to step on these pegs and they get into the soil, and that way your tripod will get very stable. Then undo this bolt. You need to hang your instrument on the tripod and open it up. There she is, our POP 2. We put it into this hole. You close it. You tighten this bolt a little bit, and then, just like in the game, you just balance it out by moving the entire stuff. You see, you get the idea. So I have balanced that out. You see, the bubble is in the middle. Well, next step is to find north. You need just roughly to find north. You need a regular compass, and it is just said that it must be somewhere there. So we found north roughly. This is the quick release rotation for the entire boussole. You rotate it somewhat to that direction you just set up. And what next you need to do is to undo the bolt which fixes the needle, the compass needle. There you go. You see, as the compass needle, it's lean to the right, so you need to rotate the boussole to the left. You have this knob over here, and this is you rotate it until the needle starts to move. You see, I'm rotating it, and the needle moves slowly. The moving needle, the stationary mark, and you are just trying to align the moving needle with the stationary mark. Well, unlike in the game, there is one in the front, and you want probably to use that instead of the back one because you can go further than that. Well, I just take away the phone because for the exact measurement, the precise measurement, you need to take away your phone at least 2 to 3 meters away from your boussole because of the magnetic interference. So after you found the magnetic north, what you need to do is to fix the needle. As a very sensitive thing, you don't want to transport or mess with your instrument while it is not fixed. So the next step, you remember that tower over there? I know the precise magnetic azimuth, precise true azimuth at that. That is 5,348. So now I need to find the magnetic azimuth. To do that, I rotate my boussole onto that, and I'm using this quick release button because I can rotate my boussole quickly. And I have this this is the aiming device. I rotate it onto the tower, and also horizontally, vertically I adjust that I want to see the tower. Good. You see, I am in the optics, and you see the tower with the with this iron sight. I got close to it, and now with the knobs I need to rotate it onto it until my boussole is aligned with the tower. That is good. What's next? Well, I need the reading. It is the thousands. That is what, 5,200, and here I have the small digits and the fine adjustment 60. 5,260. So what's next? It's simple. I know that the true azimuth of that tower is 5,348. I just subtract the 5,260, and that gives me 88 mils of magnetic deviation, declination, magnetic declination clockwise. So it's plus 88 degrees. Because when you get targeting, you're getting true azimuth, so you have to calculate with that. Why is it important, and why do they not really give something in magnetic azimuth? Because it differs. It differs from location as well as it differs from time to time. I mean, seasonally. What do I mean? Because I just well, if you do, you need to take this measurement at least 3 times and make an average, and you can get something like 87 and a half, whatever mils, the magnetic declination in this location. But you must be aware that this magnetic declination for this location only is valid for a certain period of time and for a certain distance, because from east to west the magnetic declination will vary very much. If I move from my location east to west about 10 or 20 kilometers, that's totally different magnetic declination. If I move, well, from south to north, it is not that drastic. From south to north I can move 50 or 100 kilometers and still the magnetic declination will not be that problematic. And it is not only the distance, it is also the season. The magnetic declination, what I just measured, will be probably valid for a season, for like spring, summer, autumn. It also varies from the distance of the sun, whatever. So you need to reevaluate your magnetic declination from time to time, like a month or 2 months. So that's what ARMA 3 gets wrong. The magnetic declination, they do not count with the magnetic declination. Somehow they, for some reason, for the sake of simplicity, they just presume that the true north is the magnetic north. It's not so. In my location, the true north and the magnetic north is 87 Russian mils off, which is what, 5.6 something degrees. Have a nice day.